Hey, this is Mr. Reed, and this is Chemistry Honors, and this is Organic Chemistry, otherwise known as OChem, OChem, OChem. And we're going to be naming some alkanes today. So we're going to be starting in organic chemistry. So you might ask, what in the world is organic chemistry? Well, organic chemistry is a fancy term for chemistry with carbons. You can see right here, I have some carbons, and it is what you're made out of. We are made out of a bunch of carbons. Anything that is an organic compound, anything that's living, is made out of a bunch of different carbons. And so hydrocarbons is exactly what it sounds like, a hydrocarbon. It's got carbon and hydrogen. It's the simplest organic compound that contains only carbon and hydrogen. So you can see CH4 right here, otherwise known as methane, is CH4. There's one carbon with four hydrogens. They are all singly covalently bonded. We have covalent bonds, and we have single covalent bonds. And you can see every carbon needs to bond the four things in order to make the octet rule, which means we know what type of shape it is. It is a tetrahedral shape, and you can see they all look tetrahedral, or 109.5 degree bond angle there. And you can see they all have four covalent bonds. And I have right here is my formula. Right here is my structural formula. Right here is what I call my ball and stick model, because it looks like a bunch of balls and stick model. And this one is called the space filling model. Okay, the space filling model. Every single model gives you some different advantages and different advantages. Our formula is giving you the advantage of knowing there's one carbon for every four hydrogens. The structural formula gives us the advantage of knowing they're all single bonds, but it does not give you the shape. The ball and stick model gives you the shape, but it doesn't quite tell you what it looks like in real life as it's filled in together. And so every model has advantages and has disadvantages. And so we're going to start with what's called alkanes. Alkanes. You can see that suffix ane, alkane, and this is when we are single bonds. So anytime we are single bonds, we have what's called an alkane. And if you have one carbon, we call that methane. Okay, methane. That ane tells you you have single bonds. Two carbons is going to call ethane. Ethane. E-T-H-A-N-E. Ethane. Three carbons is otherwise known as propane. You've heard that before. Four carbons is going to be called butane. And then from five carbons on, it's very, you know these names from previous experience. Five carbons would be called pentane. Six carbons would be called hexane. Seven carbons would be called heptane. Eight carbons would be octane. Nine carbons would be nonane. And 10 carbons would be called decane. Okay, so from five carbons on, these are normal names, normal prefixes on top of the A-N-E. If you want to know the first four, methane, ethane, propane, butane, I always think about me, eat, I can't even spell it, eat peanut butter. Me eat peanut butter. I love peanut butter. Me eat peanut butter. You can see that's a little mnemonic device to understand methane, ethane, propane, butane. Me eat peanut butter. Me eat peanut butter, methane, ethane, propane, butane. And that is all when we have single bonds. So how do we do this? How do we figure out what the formula is for something like propane? Well, think about what is prop. Prop is three carbons because me eat peanut butter. So propane is three carbons. Ane means we have single bonds. So what we're going to do is we're going to draw it out. 1, 2, 3 carbons with all single bonds. Okay, we have three carbons. We have a carbon there, a carbon there, a carbon there. Now what does each carbon have attached to it is four bonds, four covalent bonds, and we're going to fill in the spaces with hydrogens right there, H, 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 and H. And so what would be the formula for propane? Well, we have three carbons, and count up how many hydrogens we have. We have 8 hydrogens, C3H8. Now, there's a simple way that we can figure out the formula, and it is we take the number of carbons, we multiply by 2, and then we add 2. So you can see 3 carbons, we double that, which is 6, and we add 2, and that becomes 8. So that would be propane. Something like, think about something like nonane. Nonane. Non means 9 carbons. We're going to double the amount of carbons, so 9 times 2 is 18. We're going to add 2 more, which is 20. So the formula for nonane would be C9H20. So it all uses this formula. There's a different way to draw this, though, and that is what we can do kind of more of a formula model, and we can say we have CH3, CH2, CH3. You can see that showed the CH3 on the end, the CH2 in the middle, and the CH3 on the end. So we can also call it C3H8. Okay. There's another way to draw it out, and that is just called the stick model. And so you can see we're going to do this. Each one of these ends of these points means a carbon. And obviously it's filled in with hydrogens there. Okay. And this kind of shows the structure a little bit more. And sometimes my students find it's really easy to just do that. So for 3 carbons. Okay, because organic chemistry ends up being all kinds of these single bonds. And so the molecular formula of butane. Okay, so we have me eat peanut butter. That's 4 carbons. What do we do with the hydrogens? We double that and add 2. So 4 times 2 is 8 plus 2 is 10. So the complete structural formula would be we have CH3 here. We have 4 carbons, right? We fill in with our hydrogens here. Each carbon needs 4 lines, don't we? What's the condensed structural formula? Would be we have CH3, we have CH2, we have another CH2, then we have a CH3 on the end. If we condense this structural formula, we could do this. CH3, and how many of the CH2s do we have? We have 2 of those guys, and then we have a CH3 on the end. So the carbon skeleton would be just a carbon, 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 carbon. We call it a skeleton because it's stripped away from all the hydrogens. We know the hydrogens are there, which means we can use a line angle formula, which is every single point, every single end of this line is a carbon, a carbon, a carbon, a carbon, and obviously we're going to fill in with our hydrogens. So that's what the line angle formula looks like for butane. You can see these are all models. They all have advantages. They all have disadvantages to show butane. So something like hexane. Hex, how many carbons would that be? 6 carbons. What do we do with the hydrogens? We double it and add 2. 6 times 2 is 12 plus 2 is 14. We see C5H12. You can see that 12 is doubled and added 2, so we know it's an ane. Okay, and 5 would be what? Pentane. C2H6, 2 carbons is eth, and times 2 and add 2, which means it's all going to be ane, ethane. Non-ane, we've already done that one. C9, what do? We double the carbons, so it's 18 plus 2 is 20. And so we found the chemical formula. And that was naming alkanes for organic chemistry. Hope that was easy. Tune in for the next time we talk about organic chemistry. See you guys.